Hello everyone, and thank you for attending today. In today's presentation, we will go over how a service mesh fits into your microservices strategy. We'll start with some quick introductions. I'm Kevin Balaji. I'm a product marketing manager here at MuleSoft. And later I'll be joined by Chirag Narang, our product manager, who will take us through a product demo. Want to give a quick reminder that today we may be looking at items that are forward-looking, so please make your purchasing decisions based on generally available items. Some housekeeping rules before we get started. A recording of this webinar will be distributed via email within 24 hours. Please submit some questions at any time using the questions widget in the webinar portal. And finally, give us feedback. Please rate this webinar by selecting the survey widget at any point during this webinar. Let's review our agenda for today. First, we'll go over today's trends in the marketplace that are driving a need for service mesh. We'll then demystify the service mesh, talk about exactly what it is, what it can do, and if you need one. Next, we'll go into our service mesh offering, which is Anypoint Service Mesh. Chirag will come in and give us a good demo. And finally, we'll have some Q&A to wrap us up. All right, enough intros. Let's get started. What trends are driving the need for a service mesh? Let's take a look. And I'll start by stating the obvious. The demands of today's customers are higher than ever. They want a personalized and connected experiences when interacting with any brand, and they expect companies to have an understanding of their needs. Competitors know this, and they're moving as fast as ever to create these hyper-specialized products. Organizations need to move fast to keep up, and that's where microservices come in. In a microservices architecture, you build smaller, targeted services instead of large, monolithic applications. These services are faster to build, easier to maintain, and help foster agility. Recent studies tell us that 91% of organizations are using or plan to use microservices. Let's investigate this problem a little deeper. Why are microservices preferred over monolithic architectures? So here on the left, we have an example of a monolith. Typically, this is a very large application that is built as one big, long block of code. The issues with this are well documented. Monoliths are brittle. It's hard to find that one needle in a haystack of code that's causing you trouble if you do need to make a change. They're a bottleneck because the entire application is deployed to a single location. If you need to change deployments, you have to take the application down and then redeploy. And finally, they're rigid because once again, this is one long block of code built in a single language. If you want to change technologies, say you want to move from PHP to Java or Spring Boot, etc., you have to re-architect the entire application. In a microservices architecture, you have smaller, targeted services that are each meant to solve for a specific need. These services work together to form your larger application. And as you can see here in this example, we have many smaller services that work together to form a web application. Now, these are not brittle, they're agile, because you have much smaller modular blocks of code to modify. They're not a bottleneck, they're nimble. Because each service operates independent of one another, you can deploy and redeploy independent services as you need. And finally, they aren't rigid, they're flexible, because they can be built using any programming language or technology and can be modified accordingly to work with the developer's strengths. But just choosing microservices is the easy part. With a microservice architecture, you have multiple teams building a variety of services using languages and technologies of their choice. And this comes with its own set of challenges, and studies reflect this. 99% of organizations adopting microservices report challenges. And here you can see some of the common challenges that we see with adopting microservices architectures. Let's review them. As we mentioned, in a microservices architecture, individual services interact with one another to compose a larger application. These services work often with one another through network calls. Each network call needs the appropriate levels of authentication and authorization to ensure that an unauthorized user isn't accessing the service with any malicious intents. So in this example, what if a hacker found out that we have an orders API on our network and they tried to call it? Ideally, the orders API has a way to recognize if the caller is indeed an authorized caller and knows how to authenticate if the caller is indeed who they say they are. Imagine this problem as you scaled out your microservices architecture with hundreds and maybe thousands of services. This means that we need to make sure that each inter-service communication is secure. and that unwanted consumers aren't introducing threats into our network. Once we've ensured the appropriate levels of authentication and authorization, traffic will start to flow across your microservices. And as we mentioned, you'll likely have several services making calls at once. We need to ensure that traffic is routed in the most efficient manner to ensure that your application is performant. To do that, you'll need communication guidelines, load balancing, and other governance considerations. Now, any service can have something go wrong at any moment. What if a service is trying to access another service that's offline? What kind of fault tolerance is built in to make sure that our application is still resilient in that scenario? We need to build in guidelines to handle these situations as and when they occur. Finally, in a microservices architecture, it's likely that services belong to different groups. You're likely to be siloed in the way that they manage and inconsistent in the policies and security that's enforced across your microservices architecture. To compound the problem, different teams are probably using multiple management consoles, making it hard for you to get a single view of your microservices. Now, if you notice, most of these challenges stem from one main concept: multiple teams owning different services that are built in different languages that each have their own management and security concerns. Now, one option is that we can custom code all this logic into our services. We can specify within each single service exactly what authentication and authorization mechanisms we'll use, what responses to give if a service is down, what rate limits or tiers that we want to specify, and so on. But that would defeat the very reason to go to microservices. So how can we empower these teams to build with the technologies that are best suited to them and take away all these governance considerations? And that's what leads us to the need for a service mesh. So let's take a look. Okay, so what exactly is a service mesh? So a service mesh is an architectural pattern for microservices deployments. Its primary goal is to make sure that service-to-service communications are secure, fast, and reliable. It's typically used within containerized environments such as Kubernetes clusters. Now, in a service mesh, typically each service has a sidecar proxy that handles the service-to-service communication. The sidecar proxy takes care of all the security, routing, and monitoring of all of these inter-service communications within the Kubernetes cluster. And this traffic that goes within the cluster across services is what we call east-west traffic. It's traffic that goes east and west within the walls of our cluster. And each instance of the proxy is connected to a control plane, which provides a method to manage the mesh. The security and communication rules behind your inter-service interactions are directed through this control plane. Any developer can configure and add policies at the control plane level and abstract the governance considerations behind their microservices, regardless of the technology used to build. Popular open source service mesh technologies such as Istio have emerged to help customers take advantage of this architectural pattern. So how does that solve for the challenges we talked about? So now we can apply policies at the control plane level for authentication and authorization, which will direct sidecars to act accordingly during any inter-service network call. So popular policies include auth-n, auth-z, encryption, or mutual TLS to help secure communications and transport across services. Similarly, traffic can be routed through traffic management policies, where you can dictate how traffic should be prioritized. In a service mesh, there is built-in fault tolerance to deal with network failures or failed inter-service communications. You can also apply policies such as circuit breakers to handle these events in a specific way that you would like. And finally, in a service mesh, typically you have an automated load balancer that can distribute traffic across your mesh in the most efficient way possible, regardless of any policy that you might apply. And from the management angle, you have uniformity across how your east-west traffic is handled within your cluster. In a typical service mesh, you can investigate this traffic through Kubernetes logs by either each service or by each instance of an application. This also opens the possibility to forward this logging information to an enterprise monitoring tool of your choice, and that way you can gain a single view of your services. Now, a service mesh is already seen as a crucial component to companies invested in microservices. According to Gartner and IDC, companies deploying microservices to production will require some form of service mesh capability in order to scale. And while it comes a long way to solving specific microservices problems, it doesn't solve all the service needs across your enterprise. A service mesh intends to make service-to-service communications reliable, fast, and secure within a specific cluster. But in the typical enterprise, several services will also have consumers outside of any one specific domain. You might have web apps, mobile clients, or developers that are trying to access a microservice-based application or individual microservices themselves. And typically, this is where API management comes in. So specifically, API gateways, which are more heavyweight in CPU and memory that they use, are put in place to handle traffic coming in from external consumers, or what we call as north-south traffic. API management also has more policies that are put into place to protect this north-south traffic. Some common ones are rate limits, SLA tiers, and much more. Furthermore, after you've built out all these microservices, you'll likely have opportunities to discover and reuse them to accelerate the delivery of future projects. However, each team or individual will likely hold the expertise to the service that they created. So it's difficult to drive adoption and reuse across an organization. Some API management solutions offer developer portals that help you with cataloging of services to solve for this very problem. But this isn't considered table stakes among API management vendors just yet. So if they don't have it, you may choose to invest in another developer portal for this very purpose. In the end of all this, your microservices, your APIs, and even your monoliths ultimately make up your ecosystem of services. And across this ecosystem, it's very easy to end up with a lot of different clusters, service meshes, API management tools, and developer portals to manage. The North Star to all of this, we want to discover, manage, and secure any service in one single unified platform. And that brings us to our service mesh offering, which is Anypoint Service Mesh. So let's take a look. Before we get into our service mesh offering, a quick review of Anypoint Platform, the single product for integrations and APIs. With Anypoint Platform, you can empower your business to connect any system, app, or data source using pre-built connectors, templates, and drag-and-drop tools to integrate anything. You can securely unlock your data wherever it resides with APIs and enable teams to self-serve at scale through a central marketplace. Now, MuleSoft customers can realize a microservices architecture using Anypoint Platform and our API-led approach. And these microservices leverage the Mule runtime engine and become a part of the customer's application network, a way to connect applications, data, and devices through APIs. As you build up your application network, your building blocks can be used for the next project and the one after that, making each project faster and faster. So in this example, maybe you started with a simple integration, and some of the work in that can be reused to build a shipping and fulfillment app. And now with all of your previous work, you can now build an inventory application or a new customer experience. And each project gets faster and faster, reusing the building blocks that came before it. Now, Anypoint Platform already brings full lifecycle API and service management capabilities to support your application network. We recognize, however, that microservices exist outside the MuleSoft ecosystem that do not leverage the Mule runtime engine. And that's why we are excited to introduce Anypoint Service Mesh, a MuleSoft solution that provides discoverability, management, and security for any non-MuleSoft service deployed to Kubernetes into Anypoint Platform. By extending Anypoint Platform to any microservice, Anypoint Service Mesh allows customers to expand their application network to any service, Mule and non-Mule. With Anypoint Service Mesh, you can maximize adoption and reuse of your non-Mule microservices by adding them to Anypoint Exchange. With all your services discovered, you can use Anypoint Platform as a central point of management and governance of all services. And finally, you can ensure security and high availability across all your services by default, with policies applied directly from Anypoint Platform. Let's go over how this works. So on the top, you have Anypoint Platform, which brings full lifecycle service management capabilities for microservices built with the Mule runtime engine. Those mules could be deployed within Cloud Hub or a runtime fabric on premises. We're now introducing non-MuleSoft microservices built in any language into Anypoint Platform. This is what you see on the bottom right. To do this, we work with your Kubernetes cluster and your own installed version of Istio, the open source service mesh technology. We'll then install a mule adapter that will allow for discovery of these services into Anypoint Platform. In this way, you can discover, manage, and secure any type of microservices from one single unified control plane. And with these non-mule services available within Anypoint Platform, we've just extended the application network to any type of microservices, empowering you to build according to your strengths. We can apply the full power of Anypoint Platform to any kind of service, from API management to monitoring to Anypoint Exchange. Let's see this in action with a demo. Alright, so enough slides. For today's demo, we're going to take you through a use case. And to speak to this use case, we have a fictitious company. Specifically, we'll see today's demo through the lens of Northern Trail Outfitters, or NTO, who are an outerwear, apparel, and gear retailer with both online and brick-and-mortar locations. NTO is currently undergoing a series of digital transformational initiatives to improve their customer experience. And this is Jackie, a Director of Innovation Technology at NTO. And she's tasked with some crucial projects within this new digital transformational initiative. Specifically, she is to extend a new purchasing experience to different omnichannels, such as web, mobile, and smartwatches. Her first project is the web purchasing experience. Let's take a look at NTO's current landscape. NTO is a MuleSoft customer, and they have a number of apps running on Anypoint Platform. Independently, Jackie has spun up a team to build that new web purchasing experience for NTO. This team has built this experience using a microservices approach as seen here. These were all built in different languages according to the strengths of the team, and are currently deployed in NTO's AWS private cloud within a Kubernetes cluster. We're actually going to take a look at this application. We have one built. So this is NTO's e-commerce experience. It is a fairly straightforward e-commerce experience. You go ahead and select what you want, you add it to your cart, and then it's a fairly straightforward checkout process from there. You have some customer information, you have some payment information, and then you go ahead and place your order. So as you can see, this is kind of all those different services coming to life: your customer, your inventory, your payments, your orders. Jackie's very excited about the new application and the customer experience that it will drive. But she does have some concerns. As we described before, working with microservices does come with a set of challenges. And these challenges are exactly what we talked about before. Now, how do they specifically relate to NTO? Since these services are managed by different subteams, Jackie wants to avoid any silos. She wants to manage all services from one single unified platform. Within this application, there are several internal service-to-service calls made. Jackie needs to ensure that these interactions are secure, fast, and reliable. At this time, no protections have been applied. Furthermore, the web experience is externally facing. It can be called from any web application. Jackie wants to extend some common API management practices to this service. Finally, the web purchasing experience is just the start. Jackie will have to extend this experience to different omnichannels. She wants an easy way for other developers to discover and reuse a lot of the good work that has already been done. NTO already gets a lot of these benefits today through Anypoint Platform and their application network. Jackie is going to use Anypoint Service Mesh to extend the power of her application network to these non-MuleSoft services. Let's see how she'll do that. And with that, I'm excited to introduce Chirag Narang, who is our product manager for Anypoint Service Mesh, and he's going to take us through this demo today. Chirag, take us away.
Thanks, Kevin. Morning, everyone. In this demo, we'll see how Jackie can install Anypoint Service Mesh on her Kubernetes cluster, manage all services from one single platform, then ensure her east-west service-to-service traffic within the Kubernetes cluster is secure and reliable. Then extend the power of API management to externally facing consumer services. And then finally discover and reuse microservices to accelerate project delivery. So let's see how Anypoint Service Mesh can help. To start, Jackie goes to Anypoint platform, and within that she goes to API Manager. Here she can see her current Mule services in a single pane view. All these APIs are fully managed and governed at this point. What she wants to do is she wants to bring in her non-MuleSoft services, which are running inside a Kubernetes cluster, into the same view so she can manage all these services consistently. To start, Jackie checks her services are running within her Kubernetes EKS cluster. And let's check the status of all my services and pods. Here, Jackie can see the services are running inside the NTO-payment cluster. Now she's going to make sure that Istio is also installed on this cluster. She's going to check for the pods running within the Istio-system namespace. Now Jackie also sees Istio is running with all its underlying components. Now it's time to install Anypoint Service Mesh. To make installation and management as easy as possible, we have made a command line utility called as ASM Cutter for Anypoint Service Mesh. But if you are an experienced Kubernetes operator, you can always use declarative configs, CRDs, to fully manage and operate Anypoint Service Mesh. So let's just clear the screen and see how does the command line utility look like. And here Jackie can see all the different commands at her disposal. She's interested in creating an adapter, and she needs to collect client ID secret from the platform. She needs to provide the size of the adapter. Let's see what are different sizes we have available for the adapter. So there is a command to check the sizes. So there are 3 different sizes for adapters, all handling different levels of APIs based on the CPU and memory allocation given. As you can see, the small adapter uses half core with 1 gig of memory, and it can manage up to 25 APIs. And if you want to go for a bigger adapter, large one is 2 CPU, 2 cores, 2 gig of memory, and it will allow Jackie to manage up to 100 APIs. Since she doesn't have many services, so she'll use the small size of the adapter. With all information, now Jackie will go ahead and create an adapter for her NTO-payment namespace. So let's just clear the screen. All right, great. So now that the adapter is provisioned, the next step is that Jackie has to discover her services from the Kubernetes cluster into Anypoint platform. To do that, she has to fill in pre-built config templates, which are provided by MuleSoft. So let's go ahead and look at those templates. The first template, what it does is it creates an API within Anypoint platform. The template is called a service instance. It belongs to the service catalog object type in Kubernetes. Here, Jackie must pass the environment ID as she would like to deploy the service, where she would like to deploy the service, which she can collect from the platform. It's going to be available inside API Manager. And then she provides the name of her service. This is the name by which we will see the service in the platform. And finally, she has to provide a version and an instance label, just as she does for Mule applications today. Finally, Jackie must pass her Anypoint platform credentials. This is to make sure that there is proper level of access control on who can create APIs within Anypoint platform. Notice how she has kept these in a Kubernetes secret, so she doesn't have to write them out here in plain text. Next is the service binding. Now, Jackie can bind her microservice in the Kubernetes cluster to an API in the platform. What she has to do is she has to create a 3-way association between the API that was created in the previous step, the name of her microservice, in our case customer service, and finally the adapter that we had created in the previous step. So by applying these two templates, she can automatically create an API in the platform, and she can create an API binding. You would do this step for every service that you want to discover from Kubernetes into any point platform. The beauty of this step is, as you can see, all these are declarative configs. So this can easily fit into your existing CI/CD pipelines. You may have a CI/CD pipeline, which is building your Docker images and finally building your deployment configs. So you can embed these CRD, these custom resource definitions in those pipelines. So as soon as the deployment is going to finish, it will automatically create an API and bind it for you. So for the purpose of demo, Jackie has already completed this step for all of those 5 services that Kevin talked about. So now all has to do is just run one command and services will be discovered within any one platform. So let me apply this config. So that's it. Now Jackie will have fully discovered all these services within any one platform. So let's go back to the platform and see how does it look like. So Jackie is back in API Manager, and she's going to refresh her view here. So I can still see the previous Mule services that we have seen at the starting of this demo. So I'm just gonna filter my view based on the taxonomy.
So just want to clarify for everybody what taxonomy means here. NTO payment is the name of the Kubernetes cluster from which these non-Mule services are coming from. So Jackie here is able to search by the namespace of that cluster and get these non-Mule services in one view.
Great. So as soon as I define this view by searching to see only the non-Mule microservices from our cluster, this is great. Now Jackie can manage all her services from one unified platform. All these microservices, which were external to any point platform, are now available within the same single pane view. From here, Jackie can extend the full power of our API and service management capabilities to these services. For the purpose of this demo, let's use the customer API as an internal service that we want to protect. Let's consider that it needs to be secured using a client ID policy, so no one is able to just access the service without proper authorization. To ensure the security, Jackie is going to open that API. And as you can see, this API is managed as basic endpoint with non-Mule application managed by any one service mesh. And from here, Jackie is going to go into the policies tab. And you can see that no policies apply, so she'll go ahead and apply the client ID enforcement. Here you can see several policies which are available out of the box in the platform. However, users are not restricted to the policies which are available in this UI. You can still go ahead and use any Istio policies from the command line, just as if you would using Istio on your own, right? So I'm going to pick client ID enforcement with few single clicks. I'm just going to configure to use it with client ID secret and apply this policy. So now the customer service is protected using client ID enforcement. So great. Now we have established security and governance over the east-west traffic. But how about the north-south traffic? How about the ingress patterns? And as we know, the web experience API is the API which is externally facing, which can be called by any web application. So it is best practice to front such services with an API gateway. So the service is not directly overloaded with more traffic than it can handle, and security is applied at the gateway level, and service is not exposed to any malicious actors. This is already available in the platform today. You can create an API gateway with few clicks. So let's say this is our ingress gateway. I'm going to create a proxy, and here you have options of deploying this gateway proxy on Cloud Hub, hybrid gateway, which could be running any private cloud, or onto Runtime Fabric. I'm going to choose Cloud Hub and create a gateway. And here the implementation URI is the ingress endpoint for my web experience API, which is this one. to pick a mule version and deploy this gateway onto Cloud Hub. So it was that easy. With a few simple clicks, now I'm able to establish security and governance on my north-south traffic as well, and you can go ahead and apply any policy that you would like. There's a huge policy portfolio of 18 policy across different segments: security, compliance, quality of service, transformation. So you could pick any policy to protect your north-south traffic as well. So now let's go back in our e-commerce into your application and try to go through the checkout experience once again.
So here, Jackie is actually accessing her web application through the API gateway. And if you notice, she's accessing it through the specific URL that she assigned when she created the API gateway that went on top of the web experience API. Carry on, Chirag.
Let's pick a product, add to cart, and do a checkout. So this is a place where the UI service is trying to call the customer service to fetch the customer records. So if you recall, we have secured our customer service using client ID enforcement. So let's see what happens if I try to access customer records now. This time we are stopped. This is because the services accessing the customer service do not have the appropriate client ID and secret. The service owners would have to request access from Exchange and then include the client ID secret within their service calls to access the customer service. So now we have secured both north, south, and east-west traffic. What if Jackie wants to see the API analytics for her service? Jackie is taken to Anypoint Monitoring, which is the single source of truth for monitoring APIs and integration. Here you have built-in dashboards, which are provided by MuleSoft. And if you like, you can build your custom dashboards to build an end-to-end experience. So let's try to check the API analytics for customer service that we had protected earlier. Hey, that's great. So I have some inbuilt metrics in terms of how many requests were there, what was the response code, different methods that were accessed, and what was the average size of the request. So you can get really deep into the health of your API, who's calling my API, how many requests have failed in a particular time frame. But that really gives you a 360 view of all your APIs and integrations in one place. So now we have seen how Jackie can extend MuleSoft's API and service management capabilities to include non-Mule services with policies, security, and analytics all applied directly from Anypoint platform. Now, how can Jackie use these newly discovered non-Mule services for future projects like she wanted? She is taken to Anypoint Exchange, the marketplace for integration and API assets. Here she sees a lot of Mule services that were already available inside her private exchange, but she also sees some of these services which were discovered from a Kubernetes cluster. So let's try to filter those services. This is exciting, as Jackie has expanded NTO's reach into what they can reuse. Her teams can reuse these services to extend their purchasing experience to mobile devices and smartwatches. Most importantly, now Jackie knows that she can empower her teams to build services with the technology that aligns best with their skill sets and best fits NTO's business needs. With Anypoint Service Mesh, Jackie has brought consistent management, governance, and security across all her services within Anypoint platform, and at the same time promoting reuse and discovery of those assets. So that's it in terms of the demo. Back to you, Kevin.
Thank you, Chirag. That was super powerful. So let's do a quick recap of what we just saw. We started with a siloed environment. We had our Mule apps managed and governed by Anypoint platform, and separately Jackie spun up a team to build this web purchasing experience using a microservices approach. Jackie wanted to avoid this siloed environment and extend the power of her application network to these non-MuleSoft services. And to do that, she wanted to use Anypoint Service Mesh. To start, Jackie installed Istio, the open source service mesh technology, onto her Kubernetes cluster. This enabled a service mesh across her web purchasing experience, with sidecar proxies next to each service handling inter-service communications, and an Istio mixer acting as a control plane to govern these services. From here, Jackie could use any of Istio's policies for authorization, authentication, circuit breaker, and much more within her Kubernetes cluster. Next, Jackie installed Anypoint Service Mesh. To do so, she provisioned a Mule adapter, which allowed for the discovery of these services into Anypoint platform. With this step, she extended her application network to all of her services, Mule and non-Mule. And after installation, we saw that Jackie had a holistic view of all her services within Anypoint platform. From here, Jackie wanted to apply east-west protections to ensure reliable and secure service-to-service communication within her cluster. And in this case, we saw her apply a client ID enforcement policy to the customer service. Next, Jackie wanted to protect any external-facing service. In this case, the web experience service could be called by any web application. So Jackie deployed an API gateway in front of her cluster to front any traffic coming into the web experience service. With these steps, we saw how Jackie could protect both her east-west and north-south traffic all from one single unified platform. Finally, we went through the platform and saw how Jackie could discover her services for reuse in future projects, manage all her services in a single pane view, and ensure security and reliability across her application network. With Anypoint Service Mesh, she's brought consistent management, governance, and security across all her services, all within Anypoint platform. Before we end today, let's go over some key takeaways. So, what is a service mesh? A service mesh helps make service-to-service communications secure, fast, and reliable. Do you need one? If you're adopting a true microservices architecture, a service mesh will likely be useful to help abstract the governance challenges that go behind microservices. But remember, there's more than just microservices. Service mesh and API management work in tandem and can be used together to govern and manage all your services at enterprise scale. And with Anypoint Service Mesh, we're looking to help you do just that by extending the power of the application network to all your services. With Anypoint Service Mesh, you can discover, manage, and secure all your services within Anypoint platform. And with that, thank you for being here today, and we will open up to some questions.
All right, let's take a look at some of the questions that have been coming in. So the first question that I see here that's asked by a few people. So what's the difference between the Mule runtime and the runtimes within Anypoint Service Mesh? And when would you use Mule runtimes and when would you use other types of runtimes? So great question. Mule runtimes are deployed, as we saw when we introduced Anypoint Service Mesh, into Cloud Hub, into Anypoint Runtime Fabric, and those are for your Mule applications. So for those of you who use Anypoint Platform today, those applications that you build on Anypoint Platform leverage the Mule runtime. Independently, you'll have other teams, other projects going on that are outside of Anypoint Platform, and those other projects will have applications that have other types of runtimes. And so those are runtimes that you can support with Anypoint Service Mesh and discover those applications into Anypoint Platform for one single pane view where you can manage and govern all your applications. Another question that I see here, do you need to install Istio separately to the Anypoint Service Mesh adapter? So that's correct. When you install Anypoint Service Mesh, we will check that the Istio components are already running. If they are not, there's links in our own documentation that will be provided to the Istio installers, which you can go ahead and install on your own. So the idea is that Istio is open source. Anyone can go ahead and install it on their own. And then Anypoint Service Mesh would work with Istio to manage and govern all your non-Mule applications. And then another common thread of questions that I'm seeing here, you only applied API management for that externally facing application. Is it only possible to apply this API management on top of externally facing services, or could I do this for all my non-Mule APIs? Again, very good question. The power of our full API management capabilities is available for any service. So you could apply a gateway and our full API management policies on top of any non-Mule service. However, the methodology that we're prescribing to and what we're seeing happen in the marketplace is that people are trying to protect those externally facing services, that north-south traffic coming in and outside of one logical cluster with API management, because that's where the API management makes more sense to have that more heavyweight gateway and more additional protections applied. So the short answer is the capability is available for all of them, but we see more often than not that it's offered or it's applied for those services that are more externally facing. And then I see a couple questions about the adapter sizing. So what is 25 APIs? What do we mean when we say a small adapter supports 25 APIs, a medium supports 50, and a large 100? So specifically, those are individual services that are deployed into your Kubernetes cluster. So if you can remember, during the installation, we had a YAML template where for each service, we first created the API in Anypoint platform and then created a binding between that API and your externally facing or your non-mule service in your Kubernetes cluster. So each instance of those non-mule services is counted as an API. So in that YAML template, if you're saying, I want to create this API bound to this service in my Kubernetes cluster, each time you do that, that's counted as an API. So you should check how many times you have that, and based on that, you should be picking your sizing. And then I see a couple questions about trial accounts. So, we're still evaluating service mesh. Is there a way that we could get a trial account that I can use during my evaluation? Yes, very good question. The answer is yes. To get a trial account, you should follow 2 steps. 1, sign up for an Anypoint platform trial account. That will give you the control plane entitlement. This is regardless of if you are an existing customer or not. Get a trial account, and then with that trial account, get in touch with your account team to get the appropriate trial entitlements for Anypoint Service Mesh provisioned to that new trial account that you created. And then from there, you can install the same way that you saw during the demo, and that's how you could test out Anypoint Service Mesh. And let's find maybe one more. So I saw that the sizes for the adapters go up to 100. So can't I manage more than 100 non-mule APIs using Anypoint Service Mesh? So yes, absolutely. The way that the adapter works is you're provisioning one adapter per namespace. So for those of you who know Kubernetes well, within Kubernetes, you can have different namespaces, essentially sections of your cluster that you provision out to different projects, teams, so on and so forth. And our adapter will support up to 100 of those APIs per namespace. So if you have more than 100 APIs, you can easily go ahead and set the rest of your APIs across different namespaces and then install those adapters across those different namespaces there. And in that way, you can support many more than 100 APIs. You can support up to whatever number you want, but each namespace will support up to 100 of those APIs. Great. So it looks like those are the common threads of questions. Hang on, there's a few more coming in. I'll answer this one other question. What types of Kubernetes environments are you supporting right now? So another good question. Right now, primarily, we're supporting AKS, EKS, and vanilla Kubernetes. But as time goes on, again, this is just the first release of Anypoint Service Mesh. We're investigating other types of container platforms that are popular in the marketplace, and we will look to add more and more support for other types of Kubernetes providers. Awesome. So with that, I want to thank everyone so much for being here today. I really hope that the content was valuable and hope everyone's staying safe. Thank you, guys.